Okay, let's do the integral of the absolute value of x from -3 to +2 with respect to x. And I'm going to do that using two methods. Now, the first way of doing this is if you just look at this function here, the absolute value of x, okay, what does this function mean? So, this means for every value of x we plug into this function, we are always going to come up with a positive value. So, regardless of the value of x that we put there, it's always going to return a positive value. That means for values that are already positive, it's just an x, okay? Because if I put in +5, it just returns 5, the way it is. But if I put in a value that is negative, so a value that is less than 0, then I would have to attach a negative so that the two negative signs multiply to give me back a positive value, because this function always returns a positive value. So I've now written my function, the absolute value of x, as a piecewise function, and this is really important for the integration part of it. Now let's continue to do the integration. So this is going to be, all right, the integral. Now remember, these are two parts. There is a part from -3 to 0 because the function is defined differently for x less than 0 and for x greater than 0. Okay, so I have from -3 to 0, that's going to be defined by -x with respect to x, and then from 0 to +2, okay, I'm not sure if you can see that. Just try to put that down. So from 0 to +2, the function is defined by just x with respect to x. Alright, so let's go ahead and do the integration here. This is -x² divided by 2. The limits are -3 to 0 plus this is x² divided by 2 from 0 up to 2. Let's plug in the limits here. If I put in 0, I'm going to get a 0. Minus, if I plug in -3, I'm going to get -9 out of 2. Plus, if I put in +2 here, that's going to be 2 squared out of 2, that's a 2. If I plug in 0, that's obviously going to be a 0. So the result is 4.5 plus 2, and that's 6.5, so 6.5. That's one way of doing this integral, by writing it as a piecewise function, Now let's look at the second method, which is essentially about graphing the function. Alright, so the second method is just a trick, it's a life hack. So the second method is going to involve graphing this function, and if you just look at this here, you can already tell what this function will look like if I graph it. So let's try to come up with a graph of this function here. This is going to be my f of x, okay? This is going to be my x-axis. As you can see, for values that are greater than 0, fx is just x. And similarly, for values that are less than 0, fx is -x, which is just this. Okay, so that's our function. It stretches up to, infinity. You just want to put those arrows to show that the function, continues upwards in that direction. And we want to integrate from -3 to +2. So let me just assume that maybe this is -3 and this is +2, okay? And we know that integration means finding the area under a curve. So let me just shade off this area here. So we're trying to basically find the area under this and the area under that. And if I have x as -3, then obviously this is going to be +3. Remember what we talked about, absolute value functions. Also, if I have +2 here, obviously that's going to be +2. And I know that the area of a triangle is a half times the base times the height of that triangle. So let's find the area of this triangle plus the area of this triangle, and that's going to be our integral. Okay, let's go ahead and do that. For the first triangle, that's a half. The base is 3 units. The height is 3 units, okay? Plus, for the second triangle, we have a half times the base is 2 units, okay, and the height is also 2 units. So that's going to be 9 over 2 plus 2, which is 6.5. Again, this is the answer we obtained previously by integrating the piecewise functions. Alright, thanks for watching this video. If you like this video, please share this, subscribe to the channel for more, and give me a comment down below, and I'll see you in the next video. Thanks.